is Visual C++ Compiler, Options and Settings for Modern Secure Applications. My name is John Ryan. About me, I trained in medicine, but I've also been a Fox user since the dark ages, and I've been a very early user of VFP C Compiler, which is my topic today, but also VFPA. And I've been using these tools in my applications since 2012. No discussion of VFPA or VFP C Compiler is complete without mentioning Mr. Chen, who is, of course, the author of these VFP add-ons. And my association with Mr. Chen is I'm a very impressed paying customer. So here's the agenda of my talk today. We're going to start by looking at why you would want to use VFP C Compiler. A brief review of installation, because I'm told that some people still have some difficulties getting it up and running. We need to cover some differences and gotchas when you're using VFP C Compiler compared to VFP9 or VFPA. And then we're going to jump in and start looking at some of the settings in VFP C Compiler to see what they actually do. And the outcome of all of this is a modern, secure application using techniques that you can use yourself. And then, of course, at the end, any questions. So if we start with why you would want to use VFP C Compiler, I don't want to spend long on this, but the best and the big answer is that VFP9 is old and starting to show its age. And previously, I gave a presentation about penetration testing. I'm not going to do it again today, except to say that prices have fallen substantially since I gave that presentation. And you've now got people offering to do penetration testing of your applications for a few $100s. So you can start to expect to see your customers utilizing that more and more. So what I've got here is a little test project, and what I propose to do is to build it in VFP9 and then start using VFP C Compiler to show the differences. So hopefully this is legible. It's a pretty standard application. It's got a main PRG. The main PRG is using some best practices you'll recognize. So we've got our sys2450, (1) to make sure it's using programs in the application rather than searching the disk. And it's got a few sub programs. It's got one form, and it's got a config.fpw using best practice settings like resource and help equals off. I think most people will recognize these settings as the recommended settings to improve speed of startup, but also for security. Okay, so I'm just going to build this application. And I'm going to put it in the VFP9 folder. All of this is provided with the resources that come with this presentation. So I've just built it. And if I now run that application, you can see what it does. But before I run it, I'm going to run this tool here. This is the Microsoft tool. It's called Process Monitor or Procmon. I have a filter here which says do not record what's happening unless the name of the process is test.exe. And you'll see the reason why I have to do that. When Process Monitor kicks off, it's already recorded 100,000 events. These are all the events happening in Windows, and we only want to look at the ones that have been caused by our application. So I'm now going to run that test.exe, and it does a few things. And I then close it. And it's a pretty basic application. I'll stop that now because it's up to 500,000 events. So this is all the stuff that the VFP9 application has been doing. And I'm sorry, but this is bad. First of all, many of you will remember win.ini from the 16-bit Windows days, Windows 3.11. And your VFP9 applications are still searching for win.ini, which is a really bad look in 2025, especially with a 32-bit application. So win.ini was a batch startup configuration file in the 16-bit Windows days, replaced by the registry with Windows 95. Now, you might understand why VFP3 did that, because it came out in 95 when most people were still using Windows 3.11. But that's a bad look today. As if that's not bad enough, your VFP9 application is looking for resources which come from the MSDN 1998 release, and those are needed for Fox help. Now, as you saw, help's turned off in config FPW, but VFP9 runtime still looks for it. It doesn't just look for the Windows help, it's looking for the DBF help that goes right back to the pre-Windows days. So these are all things that are going to start to cause consternation by anybody looking. Annoyingly, hang on. Although you've got resource turned off, the VFP9 runtime is looking high and low for foxuser.dbf. And there's not a great deal you can do to stop this. But it not only slows down your startup, but to anybody looking remotely, that looks like a potential exploit. And possibly worst, despite setting our VFP9 application up to only look inside the application or to look inside the application first, it's leaking the names of program files. So for example, test1.prg. If we go back in and have a look, very clearly test1.prg is included in the application. I'm not using paths or anything to cause it to be looked for. It's a simple set procedure. So to leak that program name is not the end of the world, but imagine if it was connect to bank.prg or myencrypt.prg. You might want to go back and have a look and see whether what your VFP9 application is leaking every time it runs. So I think this is getting to the point where it's not really feasible to still be using VFP9 in 2025. VFPA, most specifically versions after August 2025, cure many of those faults. And if you add VFP C Compiler, you end up with an application, as I can show you, which is really hardened and really hard for a penetration tester or a hacker to get at. So I hope I haven't spent too long on that. If we just carry on now. What does Visual C++ Compiler actually do? So it compiles most of the VFP code in your project into C code files, literal C language code files. And those are then compiled by Visual C++ into a DLL, which is in fact a VFP FLL. And in order to compile the C code, you need a Visual C++ installation on your machine. And the rest of it, now that includes, there's a little bit of VFP code still left there. We'll have a look at that. It's mostly calling to DLL functions or FLL functions where your code's been moved, but also things that are not code-based like SCXs and VCXs. They still need to be in the VFP project, even though most of the code's been stripped out. And VFP C++ builds that skeleton into a VFP exe. So you need a working development version of VFP or VFPA. Pretty obvious. So I'm not going to spend long on this. You need to go and download VFP C Compiler installers. And then you need to make sure you've got at least one Visual C++. And I'm saying you need VFPA. You can use VFP9. You can, in fact, use any version of VFP after VFP 6 with VFP C Compiler. My advice is don't. What you do not need is to know all about C or in fact, anything about C or about the name table index, or about FLL creation, or anything else. Right, what versions of VC have I got on my machine? Easiest way to check, in my opinion, is to run appwiz.cpl. I'm going to do that now. And as you can see on this machine, I have I don't know whether you can read that, but what it's showing is every version of Visual C++ from the dark ages right up to very modern, latest versions, 14s, in both x86 and x64 mode. So I am not going to have a problem installing VFP C++ on my machine, as long as I've also got VFPA installed. And there's your clue. So download the installer, unpack the installer, little bit of complexity involving VC install files. Make sure you read the documentation that comes with it. And this is what you can expect to see. Now, this is actually the very latest one. So this is the 14th of this month. And there are new features as of this month. So what you're looking at is a simple setup program. And this is, in fact, a VFP C++ compiled VFP application. And the special thing about it is it comes with a Visual C runtime library, which is the version 10 runtime, which is what VFPA is compiled using. But there's no VFPA runtime needed because it's actually included inside this VFP executable. And we will cover that. So when you run it, accept the licensing agreement. It wants to make sure you've got VFP installed. Validate VFP's installed. I've gone for VFP 10 or VFPA, and it is found. And I could then go for any version of Visual C that I've got installed, validate it's installed. Now I can move to this. I can select where I want to install it. And when I click install now, it's going to install VFP C++ compiler, which will work straight away. Okay, so just make sure you've got the Visual C++ sorted, because that's where most of the problems happen. I'm not going to install it now because we haven't got time. I've got a lot to do. But once you've installed it, this is what you get. So I'm just going to run briefly through the Visual C++ launch folder. You've got these Foxrun 6 to Foxrun 14s, and I'm sure many people will immediately recognize that these correspond to the versions of Visual C++. So each of these contains files that are relevant to that particular version of Visual C++, because as we know, these little changes are made every time. And when we look in this one, which is the Foxrun 10, which is the runtime library for Visual C++ version 10, we're going to come back to it, but just have a look at these 4 files here. These are the standard make files that we use to invoke the C++ compiler. And there are 4 of them. And there's also make_pack.bat. We're going to come back to it. And upx.exe is a standard compressor and encryptor of files in Windows. So I guess you can figure out why that's there. But once it's installed, either using links on the desktop or directly in the application, you simply run vc.exe. Oh, I'm in the wrong place. Go back to there, run vc.exe, and you'll become very familiar with this very bright green form. Now, I'm going to race through anything which I think is self-explanatory. You can ask questions afterwards if I've gone too fast, but I hope I don't. I'm typing that because with this screen resolution, it's easier to type it than to navigate. All right, so you need to specify a project. You can do it by navigating to it. If you do, just bear in mind that the default file type is the VCF. You'll usually need to change that to project the first time, and you can then select your project. output. Oh, that was silly, wasn't it? I'll try that again. I'll type it in again. Okay. You can leave this blank. If you leave it blank, it's going to put your new VFP C++ application alongside the project, but I'm going to change it because I want to store the VFP compiler version in a different folder so we can compare behavior between the two if we want to. Right, next is your VFP run file. This is what's going to be used to compile your application. And as of this month, the default is now Visual Fox Pro Advanced 10.1, but for the benefit of many here, I'm going to put that back to the standard VFP Advanced version. And you then get to choose which C++ compiler file you want to run. You'll recall I said to look at the make.bat files. This is the default. So without wanting to spend too long on it, the C++ compiler is an extraordinary piece of kit. Right back from the dark ages, it's able to optimize compilation in a really very clever fashion. So you can optimize, for example, for size of DLL, where it will try and move repetitive code into sub-functions that get called, or you can optimize for speed, in which case it can expand called functions and inline them into the code, or you can have a mix. So usually the default is best, but if you want to customize, this O1.bat is optimized for DLL size, the O2 is optimized for DLL speed, and the OD is a no optimizations debug version. I think in general that make.bat is your best option. You can then compile your application by clicking the Start button. Now, before I do, I'm going to turn a whole lot of stuff off. These are all the defaults, and it's better to start with nothing turned on and gradually edit so you can see what's happening. But I'm going to turn the debug mode on, because what debug mode does is it keeps a whole lot of information about the VFP compiler activity so that you can see what's happened. So if I click Start, it takes about 30 seconds to compile the application. What I'd like to show you is I can actually go into here while that's running, because it no longer needs all the resources. So the first thing is, these were not there when you looked at it before. But when you turn debug mode on, VFP C++ compiler leaves all of its working folders in place. So what happens is, for programs, the compiler prepares the code to be moved into the C++ DLL in the temp0 folder, and then the temp1 folder shows you what's going to be left to be compiled into the executable. So if we have a look in here, actually I won't go for that one, I'm going to go into this procedures folder. If we have a look at test1.prg, I'm not going to open it in VFP. So test1's got a few bits and pieces. It's got a procedure there, it's got some functions, and it's got a bit of code. If we have a look in this Fox Pro temp1 folder at test1.prg, this is pretty much the code that's going to be moved into the C++ DLL. And if we now have a look at the temp1 file, this is what's going to be left in the VFP executable after you're done. So what you can see is all the content of that procedure dummy is now inside the DLL being called by this FLL function. And you start to get a feeling now that even if someone does crack your VFP executable, this is what they're going to get. So you now need to go into the FLL and decompile it to figure out what these things do. In a nutshell, that's what VFP C++ compiler is doing. Okay, so that seems pretty easy. If we now carry on and look at some of these other functions, and I propose to run through these and show you what happens as each of them are turned on. But before we begin, I do need to do one thing. I think it's pretty important. We need that word compile could be problematic. So in the old days, C++ compiled human-readable C code into machine code that is directly run by the processor. That was the original meaning of compile. VFP compile means it converts human-readable VFP code into the intermediate P code that then needs the VFP runtime, which interprets and processes the P code. And VFP C++ compiles code by doing what I've just said, which is to extract it into the companion DLL. So when I say the word compile, I'm going to try and say C++ compile or VFP compile if I'm not talking about VFP C++ compile. And as we move along, there are some differences that are worth bearing in mind. So I don't think even all VFP old-timers may be aware when your application's built with VFP C++ compiler, there is a VFP compiler constant. It's not present in VFP A at the moment or in VFP 9, so you've got to check using type or var type first. But that little snippet of code tells you whether your application's running in VFP compiler. Hash include in plain VFP, that's used to include constant definitions, usually a .h file. In VFP C++ compiler, hash include can include project code and other content which gets slotted into your program at that point. Briefly, runtimes. You need your standard VFP runtimes. VFP C++, you need that runtime. You also need VFP core.dll, which is in the launch folder, and you might need a VFP, a VC runtime, depending what version you've used, or you can have no runtimes at all needed, as we saw with the VFP C++ installer. And the DLL that's produced, it is an FLL. It's making use of the standard VFP API, which has been slightly modified. Now, I said you don't need to know anything about this, but people who do know about FLL creation, boy, have you got some fun in store. In particular, the underscore execute in normal FLLs can pretty much run anything which can be run in the VFP command line, but the VFP C++ version can also process P code, and it can also process structured language. So it's quite advanced. And recent versions have also got an extra API to establish the name table index. Don't have to worry about that too much, but it's clever stuff. VFP C++ compiler can also compress and encrypt your executable in DLL using that UPX that we saw earlier. And just remember, you can't use the VFP debugger anymore because the code's now in a DLL, but there are alternatives. I've already showed you one that debug's quite useful, and there's another option you can use. Visual C++ allows you to inline C or assembly code right into your VFP code. And the way Mr. Chen has done it is he's used constructs which do nothing in plain VFP, but do an awful lot in VFP C++ compiler. So, for example, those first two lines of code, you've got square bracket underscore underscore C. If you include that in your VFP code, when it runs in VFP or VFPA, it won't do anything. But when you're VFP compiling it, that will insert that C code directly into your DLL. You can also include your own .c files using #include, and you can include assembly files using *include ASM. So those are the ways you can inline C or assembly directly into your VFP applications. And we will come back to this, but you can also put a foxrun.h in your project folder. And when VFP C compiler builds, it will include all of that H resource into the DLL. And less likely to be used, but we will cover it, is you could use a foxrun folder with object files. That's quite advanced. I don't propose to spend much time on that. All right, let's get going. First thing is this. Now, I would suggest even a lot of VFP old timers aren't sure what this means. So what this means is, as you saw in the test.pag that we looked at just before, go back to it. You can see that VFP compiler is replacing all that code with an FLL function. If you turn up this compiler level encrypt code to, for example, level 2, what then happens is that this function in the FLL then calls a second function in the FLL. So it's adding complexity and adding difficulty for anybody who's trying to trace your code. So, for example, this VC test A38 might become VC test A58, and VCA test 58 then calls VC test 38. So there's an extra level of indentation. And the thing to remember in VFP C compiler is that indentation adds enormous complexity. In the old days, every level of indent that you applied actually reduced the available indentation or nesting for your own code, so that by the time you got up to level 7, you were at very high risk of getting that nesting overload error. That's no longer the case. So Mr. Chen's changed the way this is implemented. But my advice is, for a big business app, leave it at level 1. As you're going to see, the rest of what's going on is so extraordinary that you don't need to be nesting your functions. Okay, compiled program files is already turned on, and that means that your PRG files are going to be compiled into the DLL. If you turn that off, they won't be. They'll be left in VFP. So why would you do it? If you turn on compile form files, that means that the code in your SCX is going to be moved into the DLL. Now, just a word for the wise. It says form, but this actually covers all of the DBF type code. So that includes VCXs and things like that. This is covered in more detail in the paper. I don't propose to dwell on it. Compile structured programming commands we'll come back to. Optimize code. Now, what this does is you actually can't see it, so I'm not going to do it specifically. Normally, the _execute API processes non-P code, which is VFP code in text form. It's uncompiled. And _execute compiles it and runs it. But VFP C compiler has updated the API so it can also run P code. And if you turn optimize code on, between 60 and 80% of your VFP code is going to be pre-compiled inside the DLL, and that will run an awful lot faster. These, I think, are self-explanatory. You can encrypt your executable file. You can compress your executable file. You can compress the DLL. If you click Include Support Library, it will then include the VFP runtime inside the executable, and you won't need to distribute it anymore. And that goes for VFP core.dll as well. And you can specify a language. PEC executable file, it does not mean what you might think. PEC executable file runs that make_pec.bat that we saw earlier. And it's basically preparing your application for thinstall or molebox packers, which compress multiple files into a virtualized executable. I'm not going to dwell on that. If you use molebox, you'll need to have a look at that .bat file and process it that way. Single-step compile mode is quite useful for debugging. So if we recall this test1.prg, if we run single-step compile mode, I think we can look at it now. So what it's done is that rather than aggregating all of your VFP code into one function, each statement or command goes into its own function, so that when you run the application, if there's an error, it's much easier to track down where the error occurred. So quite useful for debugging, not really useful in your runtime. I'm trying to do multiple things at once in the interest of speed. Turn that back off. Application debug mode. What that does is when your application runs, it produces a detailed log of every line of code. Now, it takes time to build that. So I think I've got an example here. Maybe it's... Here we go. You can see the date on that, quite recent. If we look at that, every line of code has got a start and a finish. So you can tell when that starts and when it finishes, there's been no error. And when any variable or value gets changed, or there's an equation or some sort of transformation has occurred, star records the new value of that. So it's pretty good. When you're running your code, you can see the effect of each line of code. And this is pretty useful because you can't use the debugger anymore, but if there's an error, you can actually see where it happened. I just don't think it's worth watching grass grow to actually generate that now. Application error log file. I think most of us have got our own error logs, but if you haven't, have a look at that one. All right. I'm going to turn compile form files on. And we keep going. Now we're drilling down into the obfuscation and protection type settings. Compile keywords. So this applies only to macro substitution. And rather than talking about what it does, I'm just going to do it. So what compile keyword does is in macro substitution lines of code, it actually turns the VFP keywords and commands into array variables, which then join the macro substitution. So it means, macro substitution is one of the vulnerabilities of VFP because it is a string which is directly readable. And what this does is so you see that there? That is what this feature has done. It's converted VFP commands into array variables that are accessed via macro substitution. If we go back to the original test1.prg, so list memory like &lcvar no console. So you can see what that's what's happened to it. List has changed to that. So even if someone does manage to lift this section of code, they've still got a problem. Quite hard to read what that is. Now, this only applies to macro substitution, and it does carry a cost. And the cost is you need to establish this array. And if we have a look, the array is established in your main.prg. It's going to be in this one. So if we scroll down, so the first thing your application does is establish this quite large array. Basically, what's happening is the array contains all keywords used in your application, just in case you need to use those in macro substitution. And this gets established at the start of your application, and it lasts throughout your application. And what I can tell you is that in a busy VFP business application, there's hundreds of array elements if you're using this feature, and it gets so big that sometimes it overflows into more than one array. So it's a very powerful feature, but unless macro substitution is a big part of your application, consider turning it off. I'm now going to convert forms properties into procedure.init. And I'm also going to expand inline functions, do both of those at the same time. All right, so expand inline function. Inline functions come from C++ originally. So if you use the inline function specifier in C++, rather than calling the function, wherever the function is called, the compiler will slot the code in that function into the C code at that point. So you end up with a slightly bulkier DLL, but it runs a lot faster. And in fact, the compiler can do it itself. If you're optimizing for speed, it will sometimes voluntarily inline functions. So now you can do that in VFP too. If we go into this project and have a look in, so I'm looking in FoxPro run temp 0, which, if you recall, is where the VFP compiler is putting code that's going to be transmitted into the. Okay, so that's a heck of a mess. So let's have a look at what it actually used to do. You've got this function getCaption, and you've got this comment inline function getCaption. And what that tells VFP C compiler is that this is a candidate to be inlined into your code. And if you turn on that function we just looked at, expand inline function, what it does is, it's a little hard to read, but rather than calling getCaption, it's assigned this return value into a variable, and then it assigns that value into the LC test inline. So it's mimicked calling that function without actually calling it. And you might wonder why it does that. Why doesn't it just put the value straight into here? And the reason is that in VFP, you can have functions calling each other. And if they're all inlined, then you need to have persistent values between each function so that you can accurately inline them and nest them. So if we have a look at this expand inline function, expand times tells you the depth that you want this to happen. There's an example in the paper. If you're nesting inlined functions, it will only voluntarily expand the first one, but you can actually increase that, and it will actually inline functions deeper and more deeply. Now, this is a good time to talk about modulus list. You see this quite a lot in VFP C options. The way to think of it is your commands or statements are being processed in groups of 8. And this modulus list says that in each group of 8, n plus 0, 1, 2, 3, 4, 5, 6, 7, in other words, all of them are going to be affected by this function. You can, if I, for example, deleted 4, 5, 6, 7, then plus 0, plus 1, plus 2, plus 3 would have it applied. The next 4 would be left without the expansion. And then we restart the group of 8. 0, 1, 2, 3 get it. The next 4 don't. You get the idea. So, I mean, I usually just leave these all on, but you can actually be quite cunning and craft these. If they're all slightly different, then every line of code is going to have a different combination of expansions applied. And that makes it fearfully difficult to try to decompile what's going on. So that's what that's about. Convert forms property into procedure init. So what that's about is, as I said to you, SCXs and VCXs and other table-based VFP constructs need to stay in the project. But they're also unloaded into memory with the rest of the project, and it's quite easy to pick those out. And if someone picks them out, they can just look at the properties, and some of those may be quite sensitive. So in the same way as you've got a Fox PIG temp 0 and a Fox PIG temp 1, you've got a SCX temp 0 and SCX temp 1. And if we briefly look at this screen, it's pretty basic. It's got a few functions, and some of these have a little bit of code, and pretty straightforward. So let's see what VFP Compiler is going to do to it. We look in SCX temp 0, and I actually need to load this in VFP because there's no other way to look at it. So what you'll see straight away is everything's jumped up to the left, and that is because all the properties have been emptied. If we have a look in the code, the form configures itself in the init, and every object inside there configures itself in the init. And there's a slight difference to do with text box control sources. If you're using this feature, have a look at that. There's a special setting to allow you or not allow you to do the same to your control source. Okay, and then if we have a look at it to see what's being left in VFP, which is SCX temp 1, there's nothing. So in other words, all of the properties in this form have now been moved into the DLL. So if someone does extract this form, well, good luck to them. What do you care? Okay, so moving through that quite quickly, you'll notice form and report compile options. So for VFP C Compiler, reserved means do not process this. So grid height is a special one. I don't need to belabor why not setting grid height at the start of a in the grid itself can be a problem. And text box control source, I'll show you where there's quite useful resources to look up what that's doing. Sometimes you don't want to utilize this because the text box control source may not actually exist when that init is run. So you might want to do that. And you can also reserve other properties so that they won't be compiled, and you can just list them in here. And there's also options to clean. So, I mean, as many of us know, there are comments and other resources in SCXs and reports and everything else, which are really only useful at design time, but they're still there. And this lets you clean those out. And again, I'm not going to belabor those. Similarly, for your reports, you can clean printer driver info, clean out blank comments, and delete bank objects altogether, and things like that. Okay, moving right along, we'll come back to these there. I'm going to turn that off just in the interest of speed. We're now getting into the uglification stage, where things get fearfully ugly. So I'm just going to do just this decompose complex conditionals first, so you can see what that does. This shows us another commonly seen feature in VFP C compiler, the fast expansion option. And what fast does, it depends on the particular expansion you're using, but it can do things like only affect a certain number of bytes rather than all bytes, or in this case, it substantially simplifies the decomposition we're about to see. Now this is covered in, okay, it's complaining I've got my project already open. So I have. Try again. So decomposition, rather than opening it in Notepad++, which is what I've been doing. And by the way, the reason I do that is so that I can open things while it's still building without getting into trouble. Okay, so this is the temp0 code, which, as you can see, has changed substantially. It's better to look at that in VFP itself. Oh yes, so just what you're seeing there is these foxprun temp0 and foxrun temp1 files appear in the same folder where the PRG or SCX are, and that's why these are here rather than in the root. So I'm going to open test1.prg, and if I go Tools, Beautify, what we're seeing, if we at the same time open the original source, this line here has been decomposed into a giant nested if construct, which is a bit redundant because it repeats the, have a look, it repeats this and that for each time that it functions, but it is much more complicated. And the thing to reflect is that when you compile structured programming commands into the DLL, the complexity that it adds is absolutely enormous. Each of these is adding 3 extra C++ commands in the DLL. So nesting it like this is adding absolutely monstrous complexity. If you're feeling really mean, for next adds around 20 extra commands into the DLL, and scan adds 39 extra commands into the DLL for monumental complexity. But that's what decomposition does. It's basically making your code more and more complicated for the benefit of Mr. Hacker. Okay, now we're going to go for ugly. Expand expression with evaluate, expand with CHR, expand with IIF. So what these do is they are making expressions more complicated with transformations, and it has a number of effects. First of all, it removes any possibility of a signature that somebody can look for, like looking for a particular string, and it renders the entire code much less readable. So if we go back to here, let's close that. If we go into here, so I think what you can see is the quite readable code that used to be there has now been expanded with evaluates and CHRs, and you've got IIFs. So I think the point I'm making is that the originally quite readable code is rapidly becoming quite unreadable. And this thing gets loaded into the DLL as well for someone to go and look for. So that's pretty ugly. Let's make it even uglier. Compile variable names. That then converts your variable names into obfuscated random values. And you've got a few options here. For maximum ugliness, I'm going to use MD5 code 32 characters. And there's a whole lot of other stuff you can do here. So if you want to, you can specify variable names that you do want compiled. If you want to, you can specify variable names you don't want compiled. And there's a whole lot of other options that I think people can figure out for themselves. This one's a default. You don't want to compile OLO public class method names because those get registered. And you can imagine the fun if that gets randomized. And you can also have consistent compilation of variables across multiple projects with shared files. Look, I'm not going to worry about any of that. We're just going to do it so that you can see what's happening. And I've got one thing I want to show you about it. So I think we can already have a look at this. Okay, so you might notice my variable names have all been changed to much less legible variable names. And one of them's been left. So let's talk about that briefly. The way VFP Compiler works is if you can actually, in your code, you've got quite a lot of power to tell the VFP Compiler whether you do or don't want variables to be compiled. So in general, if you use an equals attribution for a variable, unless you tell it not to, VFP C compiler will compile that variable name. If you use any other construct, so scatter or store, unless you tell it otherwise, VFP C compiler will not compile that name. And you can force VFP C compiler to compile the name by having a comment followed by variable name equals. Okay, so if we look at this code, lcvar3 is left, but lcvar4 is compiled for that reason, because that comment is there. If you delete that comment, lcvar4 won't be compiled either. But I think you'll agree that's getting pretty ugly now. But we're not done. I'm not seeing. So there's other options as well. So just for internal variable names, for things like we saw for the macro substitution, you've got some command over it. It's not as good as the MD5 that we just looked at, but you can make it Chinese characters if you're feeling obscure. And that's true for both function names and for variable names that are being compiled. Now, this file search path, over the years, this has been a cause of more grief than you might imagine. The best advice I can give you is any .h file or hash include that you've got in your project, put the search path in here. You might not need it, but put it in there. And also put search paths in for your VCX files. Trust me on this. You might not need them, but it doesn't hurt. And you can cause some files not to be compiled. And you've got anti-disassembly and anti-decompile. I don't want to dwell on these. Mr. Chen has asked me not to, but anti-disassembly injects a bit of AES code that makes it much harder to disassemble. So it only works for 32-bit because you can't have AESM code in 64-bit C++ compilation. And anti-decompile uses undocumented features of VFPA, so it's only VFPA. What I wanted to show you was the move, but for some reason I can't see it. There's a move function. I think this newest version of VFP C Compiler may have put it somewhere else. I can't find it. So most likely in your version, you'll have move and fast move options. I'm not seeing them, which is a great shame, because what move does is it injects go-to commands into the VFP code so that it actually segments and breaks up the VFP code. And when it goes into the DLL, it's got jump relatives all over the place. So now you can't just take a block of C++ and decompile it into decompile the P code. It's no longer in rational order. I don't know why I can't see it. All right. Now, you might wonder what these are here when there's encrypt options that we had a look at earlier. So you can encrypt P code and you can encrypt non-P code, and you've got your modulus list. What this does is each command in your C++ DLL is encrypted in the DLL, and it's decrypted just in time at runtime. So that removes any signatures that might be possible. Now, the trouble with that is once it's decrypted, it's then available in memory if a hacker can move fast enough. So you can re-encrypt the code after it's run. So if you imagine each line of code gets decrypted, run, and encrypted again, and you can actually see this in the C file, which we'll have a look at in a moment. Fast encrypt means don't encrypt every byte in the payload you're about to encrypt. And this works for both P code and non-P code. If you remember, if you optimize code, 60 to 80% goes into encrypted mode. Okay. Just making absolutely certain there's not something that I've done here that's going to cause trouble. I'll just draw your attention to this. You can inject your own init code into the VFP executable. And now this load additional APIs, this is for compilation time. So for example, say you've got a PhD base index on a program, which on a table which is included in your application. You're going to get an error thrown when VFP C compiler tries to compile that in VFP, because it won't recognize the PhD base functions. So if that's the case, you would put into here the PhD base .vfp, and VFP C compiler would load that PhD base so that you won't see an error when you're doing your compilation. It's another trick for young players. We're running out of time. I wish I could show you the move, but I can't. There is one other thing. These ones here are pretty much redundant. These are referring to bugs, pretty much bugs in VFP 9. So not that useful. But this is very new. And I said to you, you don't need to know about FLL creation, but have a look in the paper. In your VFP application with P code, the first time the P code runs, it's got placeholders for variables in the P code, and then it's got a list of variables at the end. And the first time it runs, it converts those placeholders into an NTI, a name table index reference. And that then doesn't need to be done again. So every time that code runs, it now knows where to look in the name table index for those variables, which are no longer useful. Now, you couldn't do that with _execute from the VFP API in your FLL because it used to only accept P code. I beg your pardon, only accept non-P code. And that needs to be compiled, and then it needs to be run, and it's run anew every time. And in the old days, in VFP C Compiler, that was also true. It would run the P code and then abandon it. So you would need to redo that NTI configuration every time. That is no longer the case. The first time the code runs, it does the NTI identification and it keeps it. So if that code runs again, it's running with blazing performance. And remarkably, you can also do that with non-P code at runtime. This is not something I want to dwell on, but have a look at it. It increases the speed of your Visual C++ application visibly. And to my mind, it's running faster than VFP. So you're getting quite good efficiency improvements. This inline expand encrypt function, if you remember, I said you can have just-in-time encryption. Inlining, you won't be surprised to hear, means it actually puts the encryption and decryption code right into the C++. So rather than calling it encrypt decrypt function, it actually runs the code directly there. You end up with a slightly quicker but bulkier DLL. And this MyProtect plugin, this is something which comes with VFP. If we just quickly go into here. So if you have a look in VC SDK, there's a MyProtect folder. And this actually allows you to encrypt entire files again inside the DLL. So they have to be manually decrypted before they'll run. Now, as you can see with all the other encryption features there, you don't usually need to bother doing that with program files, but you might want to do it for an SCX, for example, and this actually includes some additional C code in your application, and there's quite a good readme.txt which tells you you then become responsible for decrypting your encrypted file at runtime before you could use it. So it's just another way of preventing hackers from accessing it. I'd have to say, in my practice, I think I got pretty good at not needing that. All right, so we're rapidly running out of time, and I would like to show you some of the other ways that we talked about embedding C code. So I'm just going to close this. I'm going to run the VFP compiled version of test.exe. So the first thing is that debugger not detected is not something that you saw in the VFP9 version, but everything else is exactly the same. All right, what's going on? So if we go into test and have a look at our main.prg, if you remember, I said in VFP C Compiler, you can include PRGs. In VFP9, this does nothing because there's no .h definitions there. In VFP C Compiler, it drops this PRG directly into the code. And if we have a look to see what that's actually doing, So it's testing to see if a debugger is working. You've got public auto verb menu, which is the name of a variable. It's a special variable. Maybe ask me in questions what that does. Then we're embedding a piece of C code. Now we've set auto verb menu equals 1. After that C code, we're testing whether auto verb menu is 0. If it's 0, there's that message box we saw. Otherwise, it throws an error. So why would auto verb menu change from 1 to 0? And it's because this piece of C code is utilizing the VFP API to do that. What it's doing is it's checking for hardware breakpoints. It's using assembly language to check for the hardware breakpoints. So there we are. There's your Visual C++ directive assembly language follows. And what it does is it deliberately provokes an error. So if you've got a debugger connected, the debugger is going to be brought up and won't know why. Otherwise, it's got this error handler which checks the hardware registers. And if the hardware registers are not set, it sets what that do. That's the API. It's setting the value of auto verb menu to 0. So this is quite complicated, but you can see that it works. I'm happy to run OllyDBG and show you what this is actually going to do, to show you that it's actually quite hard to prevent this spotting a hardware breakpoint. But I'd rather, first of all, have a look at the two other ways that we talked about embedding C++ code into your project. So here we have a VFP project. It's pretty simple. It's got a program, it's got a form, and in the program, it's got a couple of functions in the main folder. And those functions are calling myEncrypt. So what's myEncrypt? You won't recognize it. So what's happening is that in the launch folder, in the project folder, there is a foxrun.h, which includes some C++ functions to do mydecrypt, and there's also a myEncrypt. And what that's doing is you're passing a string and credentials, and this is performing AES encryption and returning the result to you entirely in C, and it's inside the companion DLL, so you don't need another DLL. And if you look down the bottom, I think VFP FLL users will recognize this little construct here instructs the compiler to actually make these into VFP accessible functions. So you've got a myEncrypt and a mydecrypt function. And when you build this application in VFP compiler, you are going to get those two functions built into the DLL automatically. So encrypt, decrypt obviously works. This use FLL, I don't know whether you noticed, but there's a copy of VFP encryption.fll in there. And what that's showing you is that it works exactly the same as using the FLL. So you don't need the FLL anymore. So that's quite a good example. if we now move on, there's another example here, which I'm not going to dwell on. So this is to show you how you can embed compression and decompression in the application using a different technique. It's similar. So you've got wrappers around external functions. The difference is that rather than having a .h file, there's a foxrun folder full of a whole lot of object files. So I think this is a bit complicated. I don't think many people are going to do it. But I think if you are an FLL person, you can actually create one of these foxrun.h files, because if you have a look at it, it is literally a proext.h, except that it's got additional functions added into it, and it's got a little bit of extra material at the end to identify those functions. So you can do this yourself, and you can build your own C or assembly routines directly into your application. All right, so if we go back to my believe it or not, we're almost at the end. So we looked at what Visual C++ does. It basically compiles all of your VFP code, or most of your VFP code, and then moves it into a separate companion DLL. It obfuscates it and complicates it and encrypts it, and then encrypts it again to make it difficult to find signatures for a hacker to work at. We can now run this application, and you will see it's got none of the exposure that you saw in VFP9, and it allows you to inline C and assembly language directly into your code. And I think these are all things that people can experiment with. Now, there are more settings. Some of them are brand new. So, for example, I think a lot of you will be aware that the auto increment that we take for advantage, version auto increment in the project builder, is not present in VFP C Compiler. It is now. There is a new setting which is not visible in the IDE we just looked at. But if you turn that on, and if you've got auto incrementing turned on in your project, VFP C Compiler will auto increment for you. So basically, my advice is don't use old versions of VFPA or VFP C Compiler. Get yourself to be a registered user. You will then receive regular emails covering new features and any bug fixes. And I guess basically the best advice I can give you is enjoy. With a few minutes remaining to us, what I'm going to do is I'm going to fire up OllyDBG. Well, I would if I could see it. Here it is. So OllyDBG is the old grandfather of debuggers. I'm going to open. So I've now got my application running in VFP in OllyDBG. If I run it, now I think I said to you, this deliberately throws an error, and then okay, so what's happened there is because I have not got a hardware breakpoint set, the test passes and there's nothing to show you. So let me try that again. If I open, I'm just going to set a hardware breakpoint. run the application, run past it. Something happened. Okay, so if you remember the test that I put, if it found a hardware breakpoint, it threw an error saying wrong value in auto verb menu. And that's what you've just seen. It's very hard to prevent this being detected because a hardware breakpoint is always visible. So that's just one of the many anti-hacker anti-hacker things that you can embed in your application. In my work, I embed hundreds of those throughout the code so that if anybody's trying to be clever, they're going to have to do an awful lot of work to try and steal my stuff. Thank you. It's almost exactly the end of time. And I think we now move to questions.